Sketch the following function. I was hoping they wouldn't ask, but now they've asked, and we shouldn't ask you to do it if we aren't willing to do it ourselves, so let's go. This is a piecewise function. It has three different sections, and so we're going to have to draw three different graphs and then take pieces out of each of them. So first, this curve behaves like 2x plus 4. 2x plus 4 is a line with a slope of 2 and a y-intercept of 4, meaning 1, 2, 3, 4. There's its y-intercept. 1, 2, 1. There's the slope of 2. And so 2x plus 4 is a straight line that looks like this. We're not going to have all of it, but I'm going to leave it all in just for a moment. We'll come back in shortly and figure out which sections are really relevant to us. But I'm going to label this 2x plus 4. The next section is x squared, which is a parabola. It passes through the origin. It passes through minus 1, 1, and 1, 1. It goes through 2, 4, and minus 2, 4, and so on upwards. It curves something like that. Okay, that'll do for the parabola. And then we have a line negative x plus 6, which has a y-intercept of 6. 1, 2, 3, 4, 5, 6. And from there, its slope is negative 1, which means it goes down 1, right 1, and gives us straight line behavior that looks like the following. And now I'm going to have to scoot that line up. Don't look yet. There we are. Okay, so my ratty parabola here is x squared. This downward sloping line is negative x plus 6, and the upward sloping line is the 2x plus 4. Okay so far? All that is curve sketching that you've learned in the past. We're just doing a lot of it at once and kind of quickly because I assume you're experts by now. Now, which parts actually count? I'm just going to switch colors here. They tell us our function behaves like 2x plus 4 as long as x is lower than negative 1. So we follow this line all along here. That's like negative 5, negative 4, negative 3, negative 2. At negative 1 is where we stop following this line. So I'm going to put an open circle there to show that's where the cutoff occurs. What happens next? From negative 1 up to 2, we follow the parabola. So there's negative 1, solid dot because they said equal. We follow the parabola all the way through 0, up to 1, and at 2 here is where the parabola cuts off. Because there is no equal symbol here, I put another open circle showing the parabola does not include this point. And finally, we follow the negative x plus 6 whenever x is higher than 2. So starting at 2, I follow this line. So when you're doing one of these on paper, I actually do all these, I sketch out these graphs just faintly using pencil. And then once I'm happy with it, I either start pressing hard with the pencil or actually get out some ink and trace out the sections that are actually part of our function. So there's the 2x plus 4, the x squared, the negative x plus 6. This function is discontinuous there. It's discontinuous again right at that corner because they never did say what happens when this function is exactly 2. This piece doesn't include 2, and neither does this one, so there really is a gap at that point. Good. Pause for breath, and then let's try some limits. Limit as x approaches negative 1 from the right. Here's negative 1. If we come at it from the right side, we're doing this. We're following the parabola. So if we want to know what's happening at negative 1, we should go to the parabola and say, hey, x squared, what do you do when we put negative 1 into you? La, 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 la. Turns out our limit there is 1. The parabola says, very close to negative 1, my y value will be very close to 1, and indeed the graph seems to confirm that. What if we come at negative 1 from the left? If we're left of negative 1, the function behaves like this, 2x plus 4. So we say, hey, 2x plus 4, what do you do when x is negative 1, or very close to it? He says, negative 1, I'm up around 2 there, he says. He doesn't actually make it. He's actually going to stop at 1.99999, but he doesn't know that. And it's just a limit after all. It's not the exact value of the function, so 2 is correct there. Now they ask for the two-sided limit at negative 1, meaning, do these two curves agree? And the answer is, nope, they do not. From the left side, we have the limit 1. The right-hand limit is 2. So for this, we can say the limit does not exist. How about, this time they don't play around with two-sided limits. They just ask us for, what is the limit as x goes to 2? Oh, sorry, that is a sided limit. It's x goes to 2 from the left. Here's 2. If we're lower than 2, then it's the parabola we should be talking to. If we're just below 2, then the function's behaving like x squared, so we can say, hey, parabola, what do you get up to when x is right around 2? And the answer is, I get very close to 4, which is indeed what the graph shows. And finally, I'm afraid I cut it off in this video, but I will. It's there on the page, and I'll write it in again. The final question, E, says, what is the limit as x approaches 2 from the right? If it were higher than 2, the function behaves like negative x plus 6. And so if we put 2 into that, we get negative 2 plus 6 equals 4. They didn't ask us, oh wait, they do ask us, sorry, my palette's covering it up. Their last question is, does the limit at 2 exist? And the answer is, yeah, it does, because our limit from the left is 4. Our limit from the right side is 4. Because they agree, we can say that the limit at 2 does exist, and it is 4 also. It's discontinuous there, but the limit does still exist.